Welcome back. We are in lesson 44. We are going to use what we learned in lesson 43 to find the missing parts of right triangles. So what we learned in lesson 43 was SOHCAHTOA. And SOHCAHTOA is sine, cosine, and tangent ratios. And it is sine equals the opposite side over the hypotenuse. Cosine is the adjacent angle, or the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent. So those are our ratios that we have available to use to solve the missing parts of these triangles. So first of all, let me get a triangle in here. Let's put in some dimensions for this bad boy. All right, this is H for hypotenuse. We don't know what this side is. We're going to call it Y. This is 24 degrees. This is a 90-degree angle, and the bottom of this is 9.5. The base is 9.5. And we don't really care what the unit of measure is right now. Right now we're just trying to figure out how to get there. And we don't know what this angle is here. So looking at this, we have to choose the appropriate ratio. And the only way that we can have an appropriate ratio is if we can get to a ratio. So let's look at what we have here. If I were to use sine, then I would have to have like the sine of angle 24. I would have to have the opposite would be y, and the hypotenuse. I can't do that. I have two unknowns. I can't find this ratio. I can't solve it. So we can't use sine. Okay, if I were to do cosine, that would be of 24 degrees. I would have to have, all right, I have the adjacent, that's 9.5, over the hypotenuse. I can't really do that. I can't back into that number. So I am going to use tangent. Tangent says to use, I have a tangent of 24 degrees. Tangent says to use the opposite over the adjacent. So I can say y over 9.5, and I can undo this operation. I can do an inverse here. So what I'll do is I'll find the tangent of 24. Let me clear this. Okay. The tangent, it's 24 tan, is this, right? So we'll call that 0.4452. And that equals y over 9.5. To undo, I have to do the inverse operation. So that is times 9.5. So I have to do the same thing to both sides because it's an equation. So 9.5 times both sides. And that I'm going to multiply times 9.5. And so my answer is 4.2, and I'm going to round it to two decimal places. So 4.23. So 4.23, this cancels, is the measurement of y. Now that I have 9.5, a leg and another leg, I can find the hypotenuse. We know how to do that. So all I'm going to do is write out 9.5 squared plus 4.23 squared equals h squared. And then I'm going to get my squares for those. 9.5 squared is 90.25 plus, let me clear that, I have 4.23 squared. All right, let's 17.8929. That equals h squared. So I'm going to add those two together. So let me add 90.25 to that. And I get 108.143. 108.143 equals h. And I'm going to do the square root of, so that I skip that step where I have the square and then I take it off. And then I'm going to go back in here and I'm going to type the way I've rounded it, 108.143. And I'm going to ask for the square root of that number. And I get 10.399. So I'm going to, because I have two nines here, I'm just going to round that to 10.4. So 10.4 equals h. All right. All right, now I just have to find this missing degree here. And that's easy enough. I have 180 minus my right angle minus the 24-degree angle that I have. That's going to be 66. So this is 66 degrees here. Easy peasy. All right, let's get another triangle. Put it right here. All right, and let's put some dimensions in for this triangle. So we have a hypotenuse of, let me get my pen back. We have a hypotenuse of 14. We have 35 degrees down here. We have M and we have X, and this is a right angle, and we don't know the measure of this angle. Well, we can find that one pretty quick. We're just going to do the same thing we did before. 180 minus the right angle minus 35. That's a 55-degree angle. So that one is easy. Do the easy ones first. Save your brain for the hard ones. All right, so now we need to look at what we have and see how we can use it to solve. So I have the hypotenuse, so I could use either sine or cosine. So in order to find the opposite angle, I need to use the sine of 35 to find x. So the sine of 35 equals, that's 35 degrees. Let's pull up my calculator. 35 sine is 0.5736. 0.5736. Okay, so 0.5736 equals, because this is sine, we want to take the opposite, that's x, over the hypotenuse, which is 14. So now I multiply both sides by 14, so this will cancel. All right, so I pull my calculator back up. So this was this, so now I'm just going to multiply that by 14. 8.03. So 8.03 is equal to x. All right, so now I still need to find m. M, I could either take the sine of the 55 degree, or I could say the cosine, which would be the adjacent leg of the 35 degree. So since we haven't done cosine yet, let's do cosine of 35. So the cosine of 35 degrees is equal to what? Clear. Let's do 35 degrees cosine. 0.8192. So 0.8192. All right, so 0.8192 equals, the adjacent over the hypotenuse. This is the adjacent because it's next to 35 degrees. So that's m is over the hypotenuse of 14. So I multiply both sides by 14 so that I can cancel this and say that whatever this is equal to m. Let me clear. Oh, wait, I needed that. So 35 cosine. Okay, there we go. We got it back. Times 14 equals 11.47. So 11.47 is m. And we have all the parts to that one. All right, this is not as hard as you thought it was going to be. It's not as hard as I thought it would be. So, there you go. Let's do one more. This one's a little bit harder. Let me paste another triangle here. I'm going to put it right here. We'll just do the math under it. All right, so for this one, we have, let me get my pen, hypotenuse of 7. This leg is 6. And this side is x. This is angle A, and this is angle B, and this is a right angle here. So what are we going to do? We don't have an angle measurement for A or B to work from. So what we need to do is find the sine using the ratio. So let's look at what we have. If we used sine, that would be the opposite, which is x. Let's do the sine of A. That would be the opposite angle would be x over the hypotenuse, which would be 7. We don't have anything we can calculate. We have one number and two unknowns. So we can't use the sine of A. That's impossible. Let's see if we could use the sine of B. So if we use the sine of B, we have the opposite is 6 and the hypotenuse is 7. So we could use the sine of B. So we could absolutely do that. So the sine of B is going to equal, let's use our calculator. Just clear this. 6 divided by 7 equals 0.8571. 0.8571. So now we have to find the inverse of this sine. So we pull up our calculator, and all we have to do is press this second key to see the inverse of the sine for this. That's going to be 58.997. I feel confident changing that to 59 degrees, don't you? So the sine here, the inverse sine is 59 degrees for B. That's what that tells us. All right, so now we should be able to find the length of x by using cosine, because we have the hypotenuse and we have the sine of B. So we put in the sine of B, which is 0.8571, and we put in the adjacent side, which is, hold up, we've got to use the cosine of B. The adjacent over the hypotenuse is what we're doing. So the cosine of B is equal to what? Let's go back to our original. So B is 59 degrees. So the cosine of B is 0.515. All right, so 0.515. All right, now we say 0.515 equals, cosine is adjacent, that's x, over the hypotenuse, which is 7. Now we multiply both sides by 7. This cancels. and we pull this back up, and we multiply this by 7. And that gives us 3.6. We could say 3.61. So equals 3.61. 3.61 is equal to x, or approximately equal to x. And where I've got equal on all of these, it's technically supposed to be approximately equal. But that's okay. That's okay. We're going to use it as equal for right now. So now we have hypotenuse. We have the length of x. We have this leg here. Let me make sure that I have the length of that leg correct. Let's find the angle that we're missing. So 180 minus the right angle minus 59 is equal to 31. So A is 31 degrees. All right, so we could easily find x the old-fashioned way. If we don't like finding it this way, we could use Pythagoras Theorem. We could say 6 squared plus x squared is equal to 7 squared. Let's just check our work and see if this is right. So we have, all right, just for the record, my triangle is not to scale, so don't let that throw you off. I use the same triangle for all the dimensions. So this is actually a little bit shorter in the book. So don't let that, the visual, impair you. So this is 36. This is 49 plus x squared. When I swim this, x squared is equal to 13. So x is equal to the square root of 13. Let's see what the square root of 13 is on my calculator. So 13 square root of 3.61. So x is correct. We found the exact same number whether we use the cosine or whether we use Pythagoras Theorem. So isn't that wonderful, though, how no matter which way we did it, we got the same answer. So x is still equal to 3.61. Isn't that fabulous? Doesn't that just prove that this was created on purpose to be a certain way, to follow the same rules no matter which way we do it? So that is how you would use, first of all, the inverse to find the degree of angle for B. And then turn around and use that same angle to find the missing leg of x. Or we could have used Pythagoras Theorem from the very beginning and found this side as well. And it would have been the same number. So it's whichever one you find easier to use, because it doesn't matter. They're both going to be right. All right, that is all that we have for, I think, for lesson 44. So I will see you in lesson 45.